All right, so here's part 2 of your Chapter 4 exam video. Number 13, solve by graphing. All right, so the first thing I would do here to graph this is let's pay attention to A. A is positive, so that means that this graph opens upward. So we can automatically rule out A and B because those both tell you, because both of these, the graph opens downward, so A would have to be negative to get one of these two graphs. Now, the next thing I would look at is the y-intercept. The y-intercept is -8. Does this one cross at -8? Yep, sure does. This one? Yep, sure does. Now, the next thing I would look at would be the x-coordinate of the vertex, which is h. And of course, that equals -b over 2a. So, -b is negative, and then 2 is b, over 2 times a, which is 1. So this is 2 divided by 2, which is 1. And then, of course, it's -1. So the x-coordinate of our vertex occurs at x equals -1. So if you look here, it appears their units are by 2's. So this is 2, which would mean this would be -1. And there's our vertex. If you look at this one here, this one is clearly positive. All right. So C is our vertex. All right. C is our vertex. All right. And then again, you can also verify with these 2 points. It crosses at +2, yes. Crosses at -4, yes. So that's another way you can use this point because this is the solution to this system. So you can use this point just to verify your answer. All right, number 14. What is the solution of the equation here? So we have 3x squared equals 21. We're solving for x, so we want to get the x by itself. So x squared equals 7. Now we need to take the square root. So x equals plus or minus the square root of 7. Because don't forget, when you take the square root of a number, you always have 2 answers. You have the positive version of that number and the negative version of that number. So x equals positive or -7. So there we go, letter B. Remember, you're going to have 2 answers when you take the square root of something, not just one. Not just one. All right. So let's look at number 15. Solve the equation. And solve it, and we can solve it however we want. All right. So we can subtract the 25 across. So we have x squared plus 18x plus 81 minus 25, which is 56. And of course that equals 0 now. So now let's try to factor this. So what factors of 56 add to 18? Okay, so you have 56, you have 1 and 56. You have 2 and 28. You have 4 and 14. Oh, there we go. 4 plus 14 equals 18. So this is going to be, and then this is plus and this is plus, so both of these are plus. So it's going to be x plus 4 and x plus 14 equals 0. Set each one of those individually equal to 0. Subtract 4, subtract 4. X equals -4. And then you have the x plus 14 equals 0. Subtract the 14, subtract the 14. So your other one is -14. So it is letter B. -4 and -14. All right. So let's keep going. Number 16, solve the quadratic equation by completing the square. All right, so x squared plus 10x. I know this is going to be plus. Let's leave a little bit of room for the plus 14 equals 0. So here we half this. We get 5. You square it, you get 25. And of course, we also have to have a minus 25 so we don't change the value. Now, this here will go to x plus 5 squared, and then this will give you negative 11 equals 0. Okay. So we can move the 11 to the other side and get x plus 5 equals 11. I'm sorry, x plus 5 squared equals 11. Now, when we have a case like this, we have x plus 5 squared equals 11. What we're going to have to do now is take the square root of both sides. So square root of this, square root of this, x plus 5, that's an x, equals positive or negative the square root of 11. Subtract 5, subtract 5, x equals negative 5 plus or minus the square root of 11. And it looks like it's letter D, because that is plus, it is negative 5 plus or minus the square root of 11. Alright, that's all there is to that. So, let's look at the next one. 17, it says rewrite in vertex form, name the vertex and the y-intercept. Alright, so we need to rewrite this in vertex form. So, let's do that by completing the square. X squared minus 12x, leave a little bit of room, put the plus 34. Half of 12 is 6, 6 squared is 36. Don't forget to put a minus 36. So y equals, now that we completed the square, since this is positive and this is negative, this is going to be negative, and this is going to be 6 because that's half of 12. This is always going to be half of your middle term. Squared minus 2. So our vertex is 6 comma negative 2, and our y-intercept we're going to get from the original equation, which is 0 comma 34. Alright, so let's bump down. It's got a plus 70, that's gone. That one's got a plus 40. This one's not right. So here the only correct answer is A. Alright, because we got y equals x minus 6 squared minus 2, y equals x minus 6 squared minus 2. Vertex was 6, negative 2. And the y-intercept you get from your original equation, which is the plus 34. Alright. That's all you got to do for that one. 18, use the quadratic formula to solve the equation. So that tells you right off the bat, when I say use quadratic formula, it's not going to factor, so you're not going to be able to solve it by factoring. So let's use x equals, why did I say x? Oh, yeah, I don't know why I erased it. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So x equals negative b is 1, so negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 2, times c, which is negative 4, all divided by 2a, which is 2 times 2. Alright, so x equals negative 1 plus or minus the square root of 1. And then negative 4 times negative 4 is positive 16. 16 times 2 is the positive 32, all divided by 4. So this is going to be x equals negative 1 plus or minus the square root of 33, all divided by 4. So which one of these does that match up to? Well, not this one, not this one, not this one, so it's got to be C, because they split it into two fractions, which is fine. I could make this negative 1/4 plus or minus the square root of 33 over 4, and it wouldn't change the value. Both of these are mathematically equivalent. They chose to write it as two separate fractions. You don't have to if you don't want to, but the answer is C. All right, the answer is C. All right, number 19. What is the number of, how many real solutions do we have? That's what we need to find out. To find out the number of real solutions, we're going to use the discriminant, which means we're going to use the quadratic formula, which means we need to get this 8x to the other side by subtracting it. So you have negative 4x squared minus 8x minus 4 equals 0. Our discriminant, remember, is just the square root. Okay, it's just the square root part of the quadratic formula, and it's more specifically what's underneath it. All right, it's more specifically what's underneath it. So b in this case is negative 8 squared minus 4 times a, which is negative 4, times c, which is also negative 4. So this here is 64. 4 times 4 is 16. 16 times 4 is also 64. And then 3 negatives means it's a minus 64. So this equals 0. When this equals 0, basically, if we look at the quadratic formula, we're going to have 8 plus or minus 0 divided by 2a, which is negative 8. Well, this is just simply going to give us one solution. So we have one real solution. All right, we have one real solution. Remember, when your discriminant equals 0, you have one real solution. When it equals a positive number, you have two real solutions. And when it equals a negative number, you have no real solutions. So equals 0, one solution. A positive number, two solutions. A negative number, no real solutions. All right. Moving right along. Number 20, we're almost done. Simplify the number using the imaginary unit I. Anytime you see an I in here, a negative underneath a radical, go ahead and pull out the I. So make this I times the square root of 360. Is that simplest terms? No. So what we can do here is 360 breaks down into 36, which is a perfect square, times the square root of 10, which is not a perfect square. And yes, you always want to, when you're breaking down radicals like this, you always want to separate it into two different radicals, one of them being a perfect square. So you can take the square root of it. That's the whole point in doing this, is so you can take the square root and get rid of one of the square roots. All right, so 36, so 360 can break down into the square root of 36 times the square root of 10. Square root of 36 is 6. I times the square root of 10. So the answer is B. The answer is B. Don't give me C. You won't get full credit. If you give me C, I may be nice and give you half credit, but you're definitely not going to get full credit because it's not simplified. And the whole thing you have to do here is simplify. This is not in simplest terms. You're not going to get full credit for this answer. All right. 21, what is the absolute value? So the absolute value of negative 1 plus 3i. Remember, it's just simply the square root of negative 1 squared plus 3 squared. So negative 1 squared is 1, 3 squared is 9. This is the square root of 10. So the answer is C. The absolute value of any A complex number is simply the square root of a squared plus b squared. Remember, b does not include the I. I is separate from the b. Like if you look up here to what I did, if you just look at this, if you ignore this part, if you just look at this, you can't tell that I'm using a complex number that has an imaginary term. Because when you do this, you don't take into account the imaginary term. Because basically all you're doing is finding the distance from the origin on your complex plane. So it's a distance. So it's going to be a real number. So don't bring the I with this and make this positive 9i squared. Leave the I over here. Don't bring it with you. Okay? 22, simplify. Well, we got to fold this bad boy out. 4 times 2 is 8. 4 times 5i is plus 20i. Negative I times 2 is minus 2i. Negative I times 5i is negative 5i squared. So 8 plus 18i. Remember, I squared is negative 1. Negative 1 times negative 5 is plus 5. 8 and 5 is 13 plus 18i. So the answer is letter B. Okay, answer is letter B. And remember, your imaginary term always, always, always goes last. It's always A plus BI. Your imaginary term will always go last. All right? So this one just a simple FOIL. 4 times 2 is 8. 4 times 5i is 20i. Negative I times 2 is negative 2i. Negative I times 5i is negative 5i squared. I squared is negative 1, so that's a plus 5 now. 20 minus 2 is 18, and then that's an 8. The 5 and the 8 is 13, and then you bring down the 18i. That's all there is to imaginary numbers. Let's look at this guy. We want to simplify him. Remember, when you simplify, you can't have an imaginary number in your denominator. So what do? Well, you multiply this by this thing called the complex conjugate. For the complex conjugate, all you have to do is change the sign on your imaginary term. So this is a positive 6i. We're going to get negative 6i. And we're going to multiply the top and bottom by negative 6i. All right? The bottom is simply going to come out to positive 36 because negative 6i times 6i is negative 36i squared, which, remember, this is negative 1. So this is going to be a positive 36. Now let's do the top. That gives you a positive 12i. I don't know why I wrote a plus there. And then this times this is going to be plus 18i squared. I squared, remember, is negative 1. So this is minus 18 plus 12i. If you look, their answers are two separate fractions. So let's break this apart. Negative 18 over 36 plus 12i over 36. This here will go to a negative 1/2 plus this will go to a 1/3, and they drop the I to the side, which is fine. You can either have it in the top or drop it to the side. So negative 1/2 plus 1/3 I, the answer is letter D. All right, the answer is letter D. All right, for 24, basically we have to factor this. So we need to find two factors that will multiply together to give us this. Well, we're in luck that this is a perfect square and this is a perfect square. The square root of 49 is 7, and then of course bring the x with it. I didn't leave myself enough room there. Let me erase these. And then square root of 36 is 6. So, of course, we're going to have two parentheses of this. Now, if we put a plus and a minus in here, okay, if we put a plus and a minus in here, positive 6 times negative 6 is negative 36, not positive. So you might be looking at me and go, Mr. Rollison, we can't do this. It doesn't work. It should be a negative 36. Well, If you remember, when you factor this right here, you're going to get an imaginary number. So this will be 7 plus 6i and 7 minus 6i. Why is that? Well, because when you multiply these two together, you get negative 36i squared. I squared is negative 1. Negative 1 times negative 36 is the positive 36, which you need here. Okay, so anytime you see, and I'm going to write it in general form, when you see an a squared plus a b squared, that's always going to factor into an a plus bi and an a minus bi. Because if you don't have those i's, your b term is going to be a negative number instead of a positive number. All right? So when you have a squared plus b squared, which is what we have here, you're going to have a plus bi and a minus bi. That's how it's always going to work. Always has, always will. All right? And look, we're on the last one. You're probably getting bored watching me. So we want to determine the solution here. All right, well, first, let's figure out which two graphs are right. Well, if you look, all the graphs are the same. The only thing different is the shading. All right, so x squared plus 6x plus 11, that's the one that opens up. It says y is less than that. Okay, y is less than that, which means we will shade outside of the parentheses, which means it can't be C and it can't be B because those are shaded inside right here. See how the shading is inside? So it can't be those. Has to be one of these two because the shading is below it. I know it still looks like the shading's above it here and below it here. It's because the shading below here goes through this region, and the shading above this goes through this region. And you can tell because out here on the edges, it's real dark. So this is telling you this dark area is where the shading overlaps. Okay, that's what it's telling you is these dark areas is where the shading overlaps. Since these are light, it means that the shading is only contained to inside of the two parabolas. All right, it means the shading is only contained to the inside of the two parabolas. So now we've got it narrowed down to these two. Now, if you look, the only difference in these two is this is a solid line here, where it's a dashed line here, and the same thing for this one. This one's a solid line, whereas this one is a dashed line. So it comes down to which line's supposed to be dashed, which line is supposed to be solid. Well, the parabola that opens up, there's no equal to bar, so it is supposed to be dashed. So the answer comes out to letter D. All right, letter comes out to letter D. So just remember, like I was saying on this one, if you look at B and C, the shading is only contained to inside the parabolas, and this little bitty sliver is where the shading overlaps. Okay, so if you look at A and D, the shading overlaps outside of the parabolas. Okay, so here it says y is less than this, so you need to shade the y's that are less than, so you're going to be shading outside of the parabola. Okay, and this one says y is greater than, and since this one opens down, these y's are greater than, so you're going to be shading outside of the parabola again. So you need the ones that the shading is outside of the parabolas, so your answer comes out to letter D. All right, because it comes down to this line is dashed, this line is solid, and that's how it should be according to our two equations. All right, so that's your Chapter 4 Part 2 video. Feel free to watch it as many times as you want or need to. Make sure when you come to class, you're ready for the test. See you tomorrow.